Okay, we're in section 13 of notes. And again, this is the ultimate hope that we have, is that you've paid attention to the lecture, you paid attention to the examples, you've done the supplementary exercises, and you've possibly done the web assignment at this point. What's the issue though? You should get an appreciation for how difficult things are. And that's when you go to the machine and see how the machine handles these difficult problems. All right. So I'm going to just, kind of type code in. I'm trying to learn as I type though. So reset, and then I'm going to type in the variables. It appears they're using two variables, X and Y. And I'm going to define those things as variables. First variable being X, the second variable being Y. And I'll type that in. And then it says f of X is a function. It's being assigned, let's see, X cubed divide by 6 plus 1 divide by 2 divide by X. That looks strange, huh? What does that mean? 1 is being divided by twice X, okay? And then it says differentiate, it's df. Now, when I say df, that doesn't mean differentiate. I'm defining a new function called df. And what is it? It's a derivative of f. You know what? I'm going to say with respect to X, just to play it safe. All right, a little different in the code over there, though. And then, yeah, I'm getting a little tired. And let me just see if this thing makes any sense to me. Again, I'm kind of typing blindly. It gives me an answer. And I kind of remember seeing 33/16. I hope you remember this, right? 33/16. Let me go back over here. I kind of remember seeing it. And we'll relate it back to a problem that we've done in the past. I think you can appreciate when I do problems, how much work is involved in doing those problems. And I really do mean that. There's work involved. There definitely work. All right. I'm looking for 33/16. And maybe I'm yamming on too much. Oh, right here. You see it? Let's see if it's the same problem, by the way. And I'm looking at it and show the arc length. Well, the function's X cubed over 6 plus 1 over 2X. I typed it in okay. And what I did was I went through the work. As I went through the work, I think you can appreciate that it's doable. I did it by hand. I typed it up and I got an answer, 33/16. And so does this Sage does it pretty good too. I'm not seeing what it did though. All right, I'm just not seeing how it did it. I'm not saying it did the same way I did it. I'm just not seeing it. Could I investigate the code base for Sage? Yeah, it's open source. You could look at it and find out how it's doing integrations. All right. I imagine it's a pretty elaborate thing. And the guy that coded this must have been pretty bright to code that. I'd have a really tough time trying to code something like that in general. Really tough time. I don't think I could do it. All right. But Sage, the people behind Sage have done that. Right. So I'm going to go back to my Sage code. And again, I'm looking, again, make sure you understand what I mean. You got to appreciate what it means to do something by hand before you can consider using a machine. Furthermore, you're not going to be able to use a machine unless you can formulate and write down what the problem is. And that's such a true statement that machines will be of no assistance to you. All right. So let me just keep scrolling down back to my Sage code. And I'm going to look at this guy over here if I can. Boy, there's a lot of work, isn't there? And this is going into this career that you've decided on is not easy. I'll copy it, but we'll discuss this with you. Sorry about that. Let me hide that. Oh, something happened wrong there. I'll go back to it later. Ooh, divergent. I wasn't expecting it. All right, was not expecting it. So I'm going to change a little tiny bit. And this happens all the time in coding. You get something, you didn't expect it. All right, but I want to go back in the notes. I want to see, do I see this problem? Right, do I see this problem? All right, so someone says, whoops, sorry about that. I didn't mean to do that. So I want to scroll back. I was wondering, do I see this problem where something's going from 1 to infinity? Yeah, I know it's annoying to look back over things. I don't enjoy it either, to be honest with you. And don't worry, we'll figure it out. Right here. All right, what right here? I see it. Right here, I see it. All right, I see it, see it, see it. I see the problem. All right, so let's talk about this. What it's going to be, it's the integration of 2 pi divided by x times the square root of 1 plus x to the minus 4, and from 1 to infinity. And remember, I got this value error, and it said, oh, the integral is divergent. All right, so what I want to do is I want to talk about this guy over here. And what we did was we used a comparison theorem. Now I'm hoping you can remember back over that. And really what it said it doesn't want you to integrate it. It wants you to use a comparison theorem to show that it was divergent. Let me read that to you. It says, the solid form by revolving the region, blah, 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 is called Gabriel's horn. What's weird about this object is it can be shown to have finite volume, but the surface area is infinite. Set up and evaluate an integral for the surface area. Well, what do I know about the surface area? I know it's infinite. So again, this might have thrown you for a shock. It says it's divergent. What do you mean? That integral's blowing up. All right, the integral's blowing up. All right, what did I do though over here? I went through the comparison theorem. I found another integral that I can compare it with that I knew was divergent. And of course, this guy over here is greater than this one over here. So if this is divergent, this would be clearly divergent. We use the divergent theorem. All right, something we've seen in the past. I want to point out this symbol over here. That's actually OO, but that's Sage's, snappy way of saying an infinity. It's an easy way for someone to type it in. It's a crutch though, I realize that. But the bottom line is you got to get used to these things. All right, let me go to the next line of code. And again, don't be overwhelmed by this. You want to be encouraged that you can look back and make sense out of the chaos that you're being presented with. And that's the whole point of learning, making sense out of the chaos that's being presented to you. So let's keep looking at it. Back over that. Sorry about the noise. I'm just scrolling here. I'll scroll my mouse pad. Let's try this one over here. All right. And let me just, whoops, sorry about that. I got to clear this thing out. Gee, that's a weird looking pot, isn't it? All right, so I got to look for that one now, don't I? And this is something I want to tell you about Sage. Sage sometimes can give you like really bad pictures. I think I've seen this one before. And again, part is just hunting back, saying, I think this has something to do with the lessons we're getting now. So I'm going to go back to my Sage and I want to look at this. And it's x to the 2/3 plus y to the 2/3. I see that. Oh, this says 4. And this was 5 to the 2/3. So it's not that problem, but it's a similar one. So let me go back. I'm going to scroll back. Hey, it's this one right here. This problem right over here. All right. So someone says, oh, the homework's awful familiar. It is, for the most part, if you can do the examples we've done in class, the homework is just slightly changed a little bit. All right. But now I got this over here. And someone says, well, you graphed it from 0 to 9 and 0 to 9 for the y. And so someone says, it doesn't look like this one. It doesn't look like this. By the way, the only section I'm graphing out is in quadrant number 1. So I'm going to try to tweak the code a little bit. And I'm going to go from 0 to 8 instead. And I want to see if it gets better. Maybe it doesn't get better. All right. So, and then I'm going to say y goes from 0 to 8. And again, you can play around with software, and that's what's great about it. Let's do that. It still doesn't look great. Now, someone says, what's going on there? There's a problem. And what's going on there? These things over here are kind of like an artifact. All right. But what I want to do is I'm going to kind of expand it out now and see if I can get, maybe a better looking picture. All right. And I'm playing. I'm not saying it's going to work for you, but I'm going to play around. So let's go -9 to 9. Let's do y -9 to 9. And let's see what happens. Wow. Negative number to a fractional power, not real. That's a problem. I'll be honest with you. That's a problem. So let's go back and let's take a look. I'm not going to use negative numbers now. I still got to go back to that 0 and 9. So this is what I want to point about, this software here. It might be tough to deal with. So what I want to do is just briefly go back to using a different product. I am jammed here. I'll be honest with you. I'm looking at this thing and I'm wondering, what could I do to make this thing work better? All right. So you know what? Maybe I should continue to work with that. And let me see if I can do that. And what I'm going to do is I'm going to say the cube root of x squared instead. All right. So I'm going to say x squared. Right. I'm going to raise to the 1/3 power instead. I'm going to see if that works. And this is, I got to say that one of the biggest problems with software is getting it to work the way you know it should be working. All right. So I'm going to say now y squared. And I'm not saying it's going to work either. I'll go back to commercial software in a second though, to the 1/3 power. And I'm going to say, let's see, that equals 4, right? And then I'm going to do the x between -9 and 9. And I'm going to do the y between -9 and 9. Again, don't be discouraged when things don't work. Wow, there, I finally got it. All right. I want to tell you what the difference is. It's the precedence of the exponents. I'm first squaring the x and then I'm taking its cube root. All right. I got the graph. I got the graph I wanted to get. All right. Same graph I got in this over here. I want to go to commercial software though. All right. So let me clear my screen out. And I'm going to close these graphs over here, which I didn't think were very good anyway. And I want to use commercial software to graph this guy out over here. All right. Now, I hope you can appreciate the graph I've given you here is a much nicer looking graph. I'm going to go to product called grapher. And what I want to do is type it in. And someone says, what are you going to type in? Exactly what I say. And what do I say? A cube root. Let me go over here. And I see cube root. Cube root of what? X squared. I'm typing exactly what I'm seeing. Plus, what am I seeing again? A cube root of what? Y squared. And what does this equal? It's equal to 4, right? I'm just going to, oh, wow, look at that right away. I don't see exactly what I see, but I'm going to zoom out. And I'm seeing a much better picture. I'm going to equalize axes, recenter the origin. I'm looking at it. I want to refine it a little tiny bit. And I'm going to pull up the inspector. And I'm going to improve the resolution of the graph. I'm going to change the color of the graph to green. I think you can appreciate the utility of this, that I'm getting a much better picture over here, including you're really seeing a very fine looking picture over here. I mean, very fine looking picture. You can zoom into these things. I'll point out what I mean by that. If I wanted to zoom into this region over here, I could do that. I get a better idea what's going on over here. And you could keep doing this all day long with this. Super simple to use. All right. So let me go over this again. With Sage, you are going to hit problems where it's going to hiccup. You have to have some experience to know how to get those predicaments. You got to stop saying, oh, it didn't work. It didn't work. It's going to work, but you've got to figure out why it's not working. Sometimes that means reading error codes. Sometimes maybe rethinking the problem, yada, yada, yada. Here's the deal though. You were never going to get to that level unless you can understand the handwork or the grunt work behind these problems. It's why it's so important you learn all that stuff that we're doing by hand. All right. Then you're going to go to the machine. Thank you for listening.